This video covers everything we did in class today on Monday, November 22nd in 8th grade honors math. Today we're working on lesson 12, using equations for lines. There's a learning target right at the top of your ClassKick. As always, make sure you've got ClassKick open while you're following along with this video. 12.1, missing center. A dilation with a scale factor of 2 sends A to B. Where is the center of dilation? Pause the video and try 12.1. We know that A is the original point, and A becomes B with a scale factor of 2, which means the distance from some center point to A is doubled. We also know that that center point needs to fall along the line from A to B. And so the distance from A to B would simply be extended to twice as long, and you would have a center point we'll call C. Remember that when we're dilating, we always dilate along a straight line. So for example, I could never dilate A with a center of C and end up over here because I can't draw a straight line from A or from C to A to the new point. Whereas when I dilate from C to A to B, as I've drawn it now, I'm moving from C through A to B, and the distance from C to A is twice as long in B to C. 12.2, writing relationships from 2 points. Here's a line. Using what you know about similar triangles, find an equation for the line in the diagram. Here's a hint. Think about how you would calculate the slope of point X and point Y. We can identify what the slope of the line is with a slope triangle from 5, 3 to 7, 7. And considering the slope triangle that's created from X to Y will help you to identify the equation. Pause this video and answer question 1. I know that the vertical distance of my purple slope triangle from here to here at the bottom is going to be whatever my y coordinate is minus 7. The reason is because the distance y, which is here to here, take away these 7 units is this small piece, and I'll draw that in purple so it's clear that this is the height of the triangle. So this purple distance is y take away 7. Because again, it's this entire length y, but we took away the 7. So it's this entire length y, but we're taking away the part that's 7 units. So instead of the entire length, we're taking away 7 units, and we end up with y minus 7. Now we have a similar situation for the base of the triangle, right? We know that the base of the triangle is not x, because x would be from our coordinate all the way over to the y-axis. Instead, it's x take away these 7 units, because our base starts right here. And so this width here is x minus 7. And so we know the height of the triangle is y minus 7, and the base is x minus 7. So we have rise over run, y minus 7 over x minus 7. And then we just need to know what the slope is. Because remember the quotient theorem, right? The vertical side of a slope triangle divided by the horizontal side of a slope triangle is going to have the same quotient as any other slope triangle. And we can see the triangle in red is 2 units wide and 4 units tall. And so it has a slope of 4 over 2, which is of course the same thing as just 2, which means that y minus 7 over x minus 7 has to be equal to 2. And again, the reason is because we have 2 slope triangles here, right? We've got our purple slope triangle with a base of x minus 7 and a height of y minus 7. And the vertical over the horizontal has to be equal to this slope triangle in red, 4 over 2. Now the slope of the line is simply 2, right? And it does appear in our equation. It's right here on the left side. It's the rise over the run, and we got it from that red triangle because we knew that the rise was 4 and the run was 2. Now the next question asks, is 9, 11 on your line? And we can determine that in one of two ways. The first is we can just look at the graph, and we actually see that point here, 9, 11. So we know the answer is yes. But the other way that we can prove this is true is by plugging in y is 11 minus 7, y is 9 minus 7, and that is equal to 4 over 2, which equals 2. So the answer is yes, because the xy pair satisfies our original equation. Go ahead and pause this video and try question 4 using the same strategy I just showed you in question 3. So you should have plugged in the coordinate pair 193 minus 7 and then 100 minus 7, and you would end up with 186 over 93. And then you would simply want to divide 186 divided by 93, which gives you 2. And so you know that it's on the line. When we first learned about equations in class and writing the equation for the slope of a line, a student asked a question that was, well, what's going to be the purpose of these equations? Like, why are we learning about them? And the reason, or one of the reasons, is so that if you're given a coordinate pair, you need to be able to identify whether or not that coordinate pair actually falls on a given line, right? And in this case, it does. It falls on the line, and we can identify that by simply plugging in the points. And that's an important component of why we write equations in the first place. Remember, you can always rewind to hear me re-explain any of those ideas from activity 12.2. Let's take a look at 12.3. Here's triangle ABC. Draw a dilation of triangle ABC with a center of 0, 1 and a scale factor of 2. So the center of dilation is going to be here, and they want you to dilate from the center with a scale factor of 2. So go ahead and pause the video and complete this dilation. So B prime will be twice as far from the center. Again, the center is that red point. B prime will be twice as far, right here, B prime. So we know it gets extended out double the distance from A. And then C prime will also be twice as far. Instead of being 2 units over and 1 unit up, it'll be 4 units over and 2 units up. And so C prime will live right here. So that's what your dilation in question 1 should look like. The next question asks you to draw a dilation with a scale factor of 2.5. So go ahead and pause this video and give that one a try. So we know that instead of multiplying the locations by 2, we're multiplying the distance by 2.5. So in the first dilation, B started as 2 spaces away and became 4. This time we're multiplying those 2 spaces by 2.5, so it ends up 5 spaces away. And I'm just going to call that B double prime. And then you know C is going to also end up being, instead of 4 over and 2 up, it'll be 5 over and 2.5 up. C double prime. So we've got our next triangle, right? And that would be an entire triangle in purple there. Question 2. Now, where is C mapped by a dilation with a center of 0, 1 and a scale factor of S? And C is this point here. So let's kind of take a look at what happened to C, right? When we start with C, I'm answering question 3 down here, we have the coordinates of 2, 2. When our scale factor was 2, so C prime, and the scale factor was equal to 2, that created C prime, we ended up with the coordinates of 4, comma 3, right? And when the scale factor was 2.5, we ended up with the coordinates of C double prime, which were 5, comma 3.5. Right? And so we can see how the scale factor is affecting the coordinates. And in particular, it's obvious that the scale factor is changing the x-coordinate by 2, right? So, for example, when our scale factor is 2, our x-coordinate is 2 times 2, which is 4. When our scale coordinate is 2.5, we know that our x-coordinate is 5, which is 2 times 2.5. And so we can see the pattern of how C is mapped by that dilation with a center of 0, 1. And so in question 4, when they ask for which scale factor does the dilation with a center 0, 1 send C to 9, 5.5, we know that if, let's call it C triple prime, was 9, 5.5, that this 9 here is 2 times the scale factor equals 9, and so the scale factor would have to be 4.5, right? And the scale factor is always 4.5. Or not always, the scale factor is 4.5 in this case of question 4, because we know we can always multiply 2 times the scale factor to produce the x-coordinate. Just like here, 2.5 times 2 is 5, 2 times 2 is 4, and in this first example, actually, the original shape, we could even say that the scale factor was 1. And so 1 times 2 is 2. We can always multiply that scale factor times 2 to tell us the x-coordinate. And you might also notice a pattern with the y-coordinate, right? When the scale factor is 1, the y-coordinate is 2. When the scale factor is 2, the y-coordinate is 3. When the scale factor is 2.5, the y-coordinate is 2.5. When the scale factor is 4.5, the y-coordinate is 5.5. It's always 1 greater, right? 4.5 and 5.5 is 1 unit greater. And so that's just a pattern we can notice from that slope triangle. And these patterns, they're the foundation of how we identify equations, which is something that we will continue to work on in our next unit. So on the final page of Classkick, you'll have a summary of lesson 12, reminding you that we can use our knowledge about slope to decide whether a point lies on a line. So when we have an equation and we can calculate a pattern in a line, we can determine whether or not a point is on the line by simply plugging x and y into the equation, which is exactly what we did up here in 2.2. After you're finished with Classkick in this video, you 1 have an exit ticket, and that's in the main folder, and 2 is you have a homework assignment. It's not homework tonight, it's studying. You have a studying assignment, which is just to study for Unit 2 test. When you're done with both of those things, you're all set. If you have any questions or any questions about the upcoming test, please let me know. There is a study guide that is posted for you in Freckle. It's in 2 parts. But if you're good on that study guide, you will be good for the assessment that we are taking tomorrow, last class before Thanksgiving break.